This lesson is on section 8.4 in your book. It's on the sine and cosine functions. This follows section 8.3, which was on the tangent function of trig. We learned in the last section that in order to use the tangent function, we had to be working with the side that sat across from it, the opposite side, and the side that sat adjacent to it, not the hypotenuse. But what happens if one of the values that you're working with happens to be the hypotenuse? Well, then you can't use the tangent function. That's where the other two functions, sine and cosine, come into play. Their definitions include using the length of the hypotenuse. So in the last lesson, we learned that the tangent of an angle is equal to the opposite side length divided by the adjacent side length. The two we are going to focus on today are the sine function. The definition for sine is you still put the opposite side on top, but on the bottom you put the hypotenuse. And cosine is the same way, except you put the adjacent side on the top of the fraction and the hypotenuse length on the bottom of the fraction. All three trig functions work the same way. They all have a little bit different formula. That's why you can use different values in the fraction. The calculator, make sure you have a scientific calculator that has the sine, cosine, and tangent buttons on it. Also make sure that your calculator is in degree mode. You cannot complete this assignment if your calculator is in radian mode. It has to be in degree mode. Okay, so to begin our lesson, the first thing we're going to look at is if I wanted to find the measure of angle A. Okay, so the angle measure of A is what I'm looking for. I'm still going to figure out what sides I'm working with. What relationship does the 18 have to the x? It's the opposite side. And what relationship does the 8 have to the x? Well, it's not the hypotenuse. It is next to A, so therefore it's the adjacent side. Okay? In this case, this one looks just like if you're going to use opposite and adjacent, you go up here. Which one deals with opposite and adjacent? That's just like yesterday's lesson. So you're going to use the tangent function. Okay? The three are used sometimes at the same time. So in this particular case, we're going to use the tangent button. Okay, so I know I'm going to use the tangent function because those are the two sides I'm given, the opposite side and the adjacent side. So I'm going to set this up, just a quick review from yesterday's lesson. I'm going to set it up and I'm going to put the angle A, which is my x value. I can certainly make this an x, equals, and I put the opposite side, which is 18, over the adjacent side, which is 8. Okay. A review from yesterday, when the angle measure is what you're looking for. You divide your two numbers, so I took 18 divided by 8, and I got 2.25. If it's more than that, if the decimal goes out farther than that, then you'll want to write 4 decimal places out. But this one only goes 2 decimal places, so that's why I stopped. Okay, so this could easily just be x as well. Doesn't matter whether you leave the angle in there or whether you call it a variable. But in order to get rid of the tangent, in order to get the x by itself, remember that I have to do the opposite. So I bring it over to the other side by making it the inverse. So I'm going to do the inverse tangent of 2.25 to get my answer, and that comes out to be 66 degrees. So that means my angle A is 66 degrees. In my next example, I'm given an angle measure, but it's a side length that I need. So again, the first thing that I'm going to do is I'm going to write what relationship each of my sides has to my angle. The slanted one, the one that sits across from the right angle, the 14 is my hypotenuse. And that would leave this length is next to the 42, but it's obviously not the hypotenuse, which means it's the adjacent side. So in order to solve this problem, I have to figure out which one of my trig functions works with the adjacent and hypotenuse sides. So I go back to my definitions and look, which one deals with the adjacent and the hypotenuse? That would be cosine, so cosine is the trig function that I'm going to use. So I know I'm going to use cosine. Now I'm going to set it up according to that definition. The definition of cosine is adjacent over hypotenuse. So I'm going to take the cosine of my angle measure, which is 42, and then on the other side I'm going to put the adjacent side, which is x, over the hypotenuse, which is 14. Okay, a review from the last lesson. When the x is on the top, how do you get it alone? You have to multiply both sides by 14. You multiply this side by 14 to make it go away, and you multiply this side by 14 to keep the equation balanced. So to get my answer, I'm going to take 14 times the cosine of 42. Put that in my calculator, and you should get 10.4 approximately for your answer. That would be the answer. That means the length of this side would have to be 10.4. On to example 3. Again, I have an angle measure, so the very first thing I'm going to do is find what's my relationship between the angle and the sides I'm working with. The 10 sits across from the 32, so it is the opposite side. And the x is the slanted side across from the right angle, so it is the hypotenuse. So I'm working with the opposite and the hypotenuse. If I go back, opposite and hypotenuse tells me sine is the function I'm going to use in this problem. So now I know I have to use the sine function. Now I'm going to set up my problem. The sine of my angle measure equals, and the definition says, opposite over hypotenuse. So I'm going to put the opposite side, which is 10, over the hypotenuse side, which is x. Now a review from the last lesson again. What happens when the x is on the bottom? Remember, it switches places with whatever's on the other side. The x comes up, and in this case, the sine of 32 would come down. So in order to get x alone, I would have to take 10 divided by the sine of 32. I can do that in my calculator, no problem. I take 10 divided by the sine of 32, and I get 18.9. That means that 18.9 would be the length of my hypotenuse in this triangle. There's an interesting way to remember which definition is which for sine, cosine, and tangent. It is affectionately known as SOHCAHTOA. I know it sounds a little weird, but it does work. Each letter stands for something. For example, the sine function. The definition of sine is opposite over hypotenuse. Cosine, the definition of cosine is adjacent over hypotenuse. And the definition of tangent is opposite over adjacent. So that's a good way to remember them. You can split them up. So, sine, you're going to use opposite and hypotenuse. Ka tells you with cosine you're going to use adjacent and hypotenuse, and TOA tells you that you're going to use, with tangent, you're going to use the opposite and the adjacent. That's a really good way to remember which definition goes with which function. That concludes this lesson on sine and cosine, and your homework is as follows.